All right, now we will do problem 27. This was done in class, but I'll do it one more time just so you guys have a review to look at. All right, a ball is thrown horizontally from the top of a 60-meter building and lands 100 meters from the base of the building, ignoring air resistance. How long is the ball in the air? And B, what must have been the initial horizontal component of the velocity? C, what is the vertical component of the velocity just before the ball hits the ground? And D, what is the velocity of the ball just before it hits the ground? And one of you guys just texted me for these review videos, so it'll be up shortly. All right, so part A, how long is the ball in the air? Let's draw our free body diagram. We're on a building, which is 60 meters tall. All right, and we throw a ball horizontally, and then it falls all the way down here, which is 100 meters away. Okay, there is our free body diagram. And it is launched with a VIX that we are looking for, all right? And using this information, we can figure out how long it was in the air. Why? Because we have all of the components of the y direction that we need. So let's write out our known x components. I like to do it in blue for x. Our x components, we have a distance of 100 meters. We have an acceleration of 0 meters per second squared, which makes our VF the same as our VI. So VIX is V naught x is equal to VFX. Okay, we know that much. All right, and we don't have either of them, and we don't have the time, right? Like I said, we're going to find the time using our y components. So in the y direction, we know that our change in y is negative 60 meters. We know that our initial velocity in the y direction would be 0 because it's kicked horizontally, so that would be 0 meters per second. And our VF y, we still don't know, but we can solve for it soon. But we do know that our acceleration is negative 9.8 meters per second squared. And we are looking for VFY, question mark, t, question mark. So first we're going to find the t because we have enough variables for that, right? So part A, how long? Find t. Simple. We're going to use delta y equals v naught y t plus 1/2 a t squared. The acceleration's in the y direction. So remember, negative 60 meters equals, this was 0, so we can just cross that out, goes to 0, equals 1/2 times negative 9.8 meters per second squared times t squared. So we end up with t is equal to the square root of negative 60 times 2 divided by negative 9.8 meters per second squared, which gives us a time of let me just make sure, 3.49 seconds. All right, so t equals 3.49 seconds. All right, so now part B asks us what must have been the initial horizontal component of the velocity. So for part B, now we have a time and we have a distance. There's no acceleration, so let's do this. So we have, we can use delta x equals v naught x t plus 1/2 at squared. This is how we get it. I'm just going the extra long route. This is the same as the v average equals x over t. So this will go to 0. Remember, our acceleration is 0, and we end up with this, which is this, right? So we're looking for our v naughts. We know that it was 100 meters, and it took 3.49 seconds to complete. So that gives us a velocity in the x direction of 28.7 meters per second. There we go. That's part B right there. Picked the correct equation, did the math correctly, and then got the correct answer. Free body diagram. Variables. Same thing with here. All right, so that takes care of part B. Part C. What is the vertical component of the velocity just before the ball hits the ground? All right, so we have to find our VFY. So we have our V naught Y, we have the distance traveled, and we have an acceleration. So this one should be fairly simple. Part C. Find VFY. So VFY squared is equal to V naught Y squared plus 2 acceleration in the y direction times the distance traveled. So this goes to 0. We had a 0 initial velocity. So VFY will equal the square root of 2AY, which will equal the square root of 2 times negative 9.8 meters per second squared times negative 60, which give us a final velocity of 34.4 meters per second, but it's going downward, remember, plus or minus. Using your logic, you get negative 34.4 meters per second. And then the last thing, what is the velocity of the ball just before it hits the ground? So we're looking for the VF. This part D, as it hits the ground, VF. So in here, VF will equal the square root of VFX squared plus VFY squared, which would be the square root of 28.7 squared plus negative 34.4 meters per second squared, which will give us 44.8 meters per second.